All right, so what we're going to be looking at now is now that we've moved on from the central tendencies, we want to see the spread of the data. So how far is this data spread out over all possible data points? Okay, so we're kind of looking at how far away can numbers be from the middle. Okay, and that's called the standard deviation. Okay, and so we're going to be looking at how to do this. Now, there is a way of doing this by hand. We're not going to do that by hand, but you guys are just going to use your calculators. All right. So there's different ways of measuring the variation in your data. There's 3 different ways. First way is called the range, which you probably have heard. Range is just the largest number minus the smallest number, or the max minus the min. Okay, that's all the range is. Max minus min. Okay, and that's your range. Now, if you want to look at something called the interquartile range, we kind of mentioned this previously. The interquartile range is the third quartile minus the first quartile. Okay? And that tells you your interquartile range, or the IQR, which is kind of the abbreviation for it. And it's another way of just identifying how far it's spread out. Okay? Again, it's just another way of using it. And the last way of doing it is called the standard deviation, which is the title of this section. And standard deviation is given by the letter sigma, okay, the lowercase sigma. And so whenever you see that lowercase sigma, we're talking about the standard deviation. Okay, and it wants to know how much it varies based on the mean. So how far it deviates from the mean. Okay, and kind of like, okay, well, the average change over this period of time is this, and so that's what it's kind of doing. Okay, so it's looking at how far away from the mean the numbers are. So if you have all these right here, and you're asked to find the range, what you do is you just take the largest and you subtract it by the smaller. So 29 is the largest, 21 is the smallest. That means your range has to be 8. Pretty simple. Now the next one, the interquartile range, what you'd have to identify is you'd have to identify your first and third quartile, which in this case is 23 and about 7.5. So as you see, it's about here and about here is where your numbers are. Okay, that's where your quartiles are approximately. And so what we do here is that we just take them and we subtract it. So we go 27.5 minus 23, and that gives us our number of about 4.5. And that's our interquartile range. So our interquartile range is about 4.5. Our range is about 8. Okay, and this is just another way of identifying the spread of it. Okay, so it's just different ways. Sometimes you want to use some, sometimes you want to use others. Okay, so to do standard deviation, what we're going to do is that we're going to use the calculator. Okay, doing it by hand, if you get larger and larger data points, takes up a lot of time. And in a statistics class, we probably would go through and do a couple of them by hand, so you can see the formula and see how it works. But for this, we're just going to use our calculator because we're able to. So under L1, what you're going to do under L1 on your calculator is that you're going to put all the data points. Okay, so all the data points that are given. So again, under Stat Edit, under L1, once you clear out everything else from L1, you're going to put in every single one of these data points. And I believe there's about 13 of them, approximately. 2, 4, 6, 8, 10, 12, 13. Yep. So it's about 13 of them. Now, when you go to Stat, when you push Stat, you go over to Calc, and you go to the 1var Stat again. Okay, this is where we identified the quartiles and everything. Well, as you look here, we've got these first, 5 or 6 that appear we didn't really deal with in the previous one. The X bar, which is the X with a line over it right here, that is called your mean. Okay, that is your mean. You should know what mean is. Okay, so that's the mean of all the data points. And so in this case, I got about 25.0769. And then the sigma x is the standard deviation that we're using. Okay, S of x and sigma x are both standard deviation, but we are going to be using the sigma x. They're slightly different. But as you see, they're fairly close. But the sigma x in this case was about 2.43. And that would be our standard deviation. Okay, so the average change or deviations from the mean, these numbers are moving away, is about 2.4. Okay, so again, we've gone through all these, and those are your numbers. Okay, so again, use your calculator when you want to find standard deviation. It's there for a reason. Okay, now there's something called a z-score. Now what a z-score does is it tells us how many deviations a certain number is from the mean. So there's three things you need to find a z-score. You need your mean, you need your standard deviation, so your x bar and your sigma, and you need the data point itself. And the data point itself will be x. And the formula to find the z-score is the change from the data point to the mean, so x minus x bar, all over the standard deviation. Okay. Your mean always goes second. Okay. So you can have a negative z-score. Negative z-score just means that it's below the mean. Okay. The x is smaller than the average. And then that tells us how many deviations we are mean. So that's what the z-score does. And now there's, again, if you take a statistics class, there's a lot more stuff you can do with a z-score, finding percentages and everything. But we're not going to do that. So over the past year, Greg has been timing how long it takes for him to go to school. Okay, he finds that the mean is about 15 minutes, and he found that the standard deviation was about 3 minutes. How many deviations from the mean, or the z-score, is he if it takes him 23.6 minutes to get to school? So what you would do is that you'd find your z-score, which is the deviations from the mean. That's what the z-score is. You would go 23.6 minus 15 all over 3. Okay, pretty simple, pretty straightforward. And then you would calculate that through, and you see you get about a 2.867. So he's about almost 3 standard deviations away from the mean. Okay, which is a kind of a big outlier if you have a lot of data points for this. Okay, so that's what the z-score does. It tells you how far away. Okay, your IRAT. First one, find your range, interquartile range, and your standard deviation of that data set. Okay, use your calculator. Makes life easy. The next one, find the z-score for the following. The mean is 45 and the standard deviation is 7. So find the z-score for 32 and 49. So 32 is going to be negative because it's less than the mean. Okay, and that is your IRAT. Okay, for standard deviation.